Okay, this is the last question. It's question C3 that we're going to do. It's a sigma notation kind of problem. It's geometric and maybe it's a little bit tricky. I don't know. Let's try. Here we go. You're given that the sum to infinity from k equals 1, you're given a formula, 4 times 3 to the 2 minus k power. It's actually k equals p. K equals p right here. Um, that is the first thing. Um, that's the formula you're given here. You're supposed to prove that it's a convergent series. Prove that it's a convergent series. Well, maybe this is k equals 1. Sorry, it's k equals p in the next question. I couldn't quite read it there. It's k equals 1. Well, if you want to find the first term, we're supposed to prove it's a convergent series. Um, you could get the first term. I could do it a little bit quicker than this, but you could get the first term just by putting 1 in here. 2 to the minus 1 is just 2 to the 1. So it's 3 to the 1. The first term is 12. Then you put in 2. 2 minus 2 is 0. The next term is 4. Well, 4 divided by 12 is a third. And you get r is equal to a third. You might see here that this is really 3 to the negative 1. That is a third. So the power r is a third. You can see it in the formula. But you just find the first two terms by putting in 1, putting in 2, and then dividing the 2. You don't even need this third one. Now there's your r. Now the reason it's a convergent series is because it meets the conditions for convergence, being that 1/3 is less than 1, but greater than minus 1. Because 1/3 fits in between 1 and minus 1, therefore the series is convergent. Because r is between 1 and minus 1. Well, that's it. That's proving it. That's showing why it's a convergent series. Now it says, if the sum of all of this, of this series was 2 over 9, to infinity, it was 2 over 9. Can you figure out what p is? Well, let's look what they do with this here. Well, they try, okay, let's start with k equals p. Okay, let's start with k equals p. If we put that in there, we would have the first term is 4 times 3 to the 2 minus p. And there you go. There's your first term right there. Now we know from before that r is equal to 1 over 3. So we've got r is 1/3. Well, all we have to do, and we've got the sum to infinity is 2 over 9. So the sum to infinity, put in 2 over 9. A, put in 4 times 3 to the 2 to the minus p, just what the first term is, putting in p first. And then r is a third, so it's 1 minus a third. If you this is 2/3. If you multiply 2 over 9 by 2 over 3, you're going to get 4 over 27 equals this stuff up here. Then you divide by 4. 4 divided by 4 is 1. So this is 1 over 27 when you divide both sides by 4. But hey, 1 over 27 is really 3 to the minus 3 power, 1 over 3 cubed. Well, now we've made the basis the same. We can go 2 minus p equals minus 3. 2 minus p is minus 3. We can add p and add 3 to both sides, and we'll get p equals 5. Add p to both sides, add 3 to both sides, and you get p equals 5. I was looking at this question, when you're looking at this 4 times 3 to the 2 minus k, I'd like to write that in a different way. I'd like to write 3 squared there because that's what it is. 3 squared is 9 times 4. That's a nice, easier to look at. It's really 36 times. And then 1 over 3 to the 1 over, oh, that's, so your minus k means really 3 to the minus 1 to the k power. The 3 to the minus 1 is really 1 over 3. That's explaining a nice, easy way to get r. And it'd even be an easier way to do the first term. It would be a little easier to work out and get to it quicker. Just another way of looking at it. Hey, I hope that helps. I hope it helps. Okay.